When it started in the early 90s, research into sequencing the first human genome cost $3 billion in 15 years. Today, one can get their own genome sequenced with only $1,000 in half a day, a million-fold reduction in cost, and a 10,000-fold reduction in time. The human genome is the new silicon wafer, and biotechnology is a field with an impending revolution, like Silicon Valley in the 1980s. In the United States alone, molecular and genetic testing is responsible for $5.5 billion of medical spending, and is projected to double every 5 years. Genetic testing is expected to be responsible for more than $20 billion as soon as 2021. It's clear that biotechnology is the next big thing. Engineers in software and electronics are used to world-class tools created by professionals in the field, available widely and cheaply. Biotech, however, has not caught up to the modern standards. Let's take a look at some of the simplest things you might want to do. All of molecular biology is moving small amounts of clear fluids between different test tubes. These test tubes are organized into plates, and someone has to put tubes in those plates. Traditional labs hire dozens of people to perform manual labor, but as we know from the technology industry, we need to design businesses that scale. People don't scale. We need robots. You can build robots to move small tubes. A hobbyist with an Arduino and a month of spare time can build one for a few $100s. We should be able to buy a tube-moving robot for less than $1,000. Instead, we have this machine. If you want to control your technology automatically, you're practically out of luck, unless you're interested in installing a 10-year-old operating system with an archaic user interface. Instead of costing a few $100s, you're stuck with having to purchase a slew of incredibly expensive pieces of outdated equipment. This tube-moving robot can cost you over $40,000. Most other technology in the field is just as bad. Do you want to move liquids from one tube to another? Be prepared to shell out hundreds of thousands of dollars for a commercial liquid handler, accessible via Windows XP only ActiveX interface. Be prepared to spend thousands of dollars on PCR machines, which can be built with open source designs for less than $600. The list goes on and on. Molecular biotechnology has long been a field dominated by large incumbents with technology from the 80s. Modern robotics, sensors, and open source software can be used to reduce the cost of necessary robotics by more than an order of magnitude. This is an industry ripe for disruption and one with rapidly growing demand and falling costs. This is where we come in. We offer to provide a modular, reconfigurable system for biotechnology research and commercial automation. We will start with a simple liquid handler, which can be reduced to a fixed platform, a 3-axis movement system built around 3 rails and a precision-controlled pump on the end. Our platform is designed to be modular and upgradable. We can extend our system with cheap components built using modern tools, including PCR machines, turbido and chemostats, microcentrifuges, and other common biotech robots. Many of these components exist, but they are much more expensive than they need to be, costing tens of thousands of dollars, if not hundreds, featuring decade-old software interfaces and sensors and actuators which have not been improved for years. We can create a single platform built around efficient liquid handling, open-source software, transparent pricing, and modern user interfaces. Our product will capitalize on the growing market and be priced competitively enough to be affordable by commercial establishments and smaller university labs. Our target is such startups and labs. By creating a modular system, we can reduce the setup cost for new labs and provide existing labs an easy and affordable upgrade path. We can reduce the cost of laboratory automation from hundreds of thousands of dollars or millions of dollars to mere tens of thousands.